CRD 4.2, Adding and Subtracting Fractions with Polynomials. We have to start this one by remembering adding and subtracting fractions. So if I have 1/7 plus 2/7, this is a fairly easy problem. And this is going to be helpful as you're trying to get through some of the more difficult ones to remember the easier ones that you should know automatically from elementary and 6th grade. 1 plus 2 I add together and I get 3. But sevenths stays sevenths because when you're adding, the denominator stays the same. So my answer here is 3/7. This one, however, has different denominators, so I need to make them the same. So I think about what number 6 and 9 go into. I could multiply 6 and 9, but sometimes that makes it more complicated and too big. So how about 18? 18, 6 goes into and 18, 9 goes into. In fact, it's their LCM. So what did I do to get 6 to turn into 18? Well, I multiplied it by 3. And I have to multiply 1 by 3 to make the fraction equivalent. So I end up having 3/18. For 9 to turn into 18, I had to multiply it by 2. So if I do the same thing to its numerator, I will get 4/18. So I have 3/18 plus 4/18. And remember, denominator stays the same, 18ths. 3 plus 4 gives me 7. Then I need to check for reducing. Can I reduce 7/18? And no, I can't. 7/18 is as reduced as it will get. So now I look at the next question. I've got 3 over x plus 1 plus 5 over x plus 1. And these denominators are exactly the same also. So in my answer, it's going to have x plus 1 as its denominator. And I'm going to take 3 plus 5 and I'm going to add them together. 8. Okay, cannot reduce this because x plus 1 is a unit. It doesn't have any matching unit on the top that says x plus 1, and 8 doesn't have anything on the bottom it can cancel with. So that's my final answer. If I were to include restrictions, I would say, looking back to the beginning problem, I would say that x cannot equal -1. Okay, moving to the harder questions. Actually, these are probably medium. 1/7 plus 2/7, let's remind ourselves, is 3/7. So when I look at a problem like this, the denominators are the same, just like sevenths. So I'm going to have x plus 1 in my denominator. On my numerator, I've got x plus 3 plus x plus 4. So let's write that, x plus 3 plus x plus 4. Well, guess what? I can actually combine things. I've got 2x plus 7 over x plus 1. I can't factor 2x plus 7. There's no GCF there. X plus 1 and 2x plus 7 are not identical, so I can't reduce them because remember, it's not 71. That's actually supposed to be a parenthesis. Those two units do not match, so you can't cancel anything. The temptation is, of course, to cancel that x, but you can't do it unless you have all multiplication. So that's my final answer. It doesn't look very neat, so let me write it over here. 2x plus 7 over x plus 1. Now looking back, what are my restrictions? X cannot equal -1. This one only differs slightly because it has a minus in it, okay? But that does make a big impact in the problem. You've got x plus 1 as your denominator. Restriction's still going to be the same. X cannot equal -1. But now I'm going to have x plus 3 minus x plus 4. And I am going to use parentheses this time because when you're subtracting, you've got to distribute that negative. So I end up getting x plus 3 minus x minus 4 all over x plus 1. That reduces x minus x cancels out. And we're going to write over the tree frog. Sorry, dude. X minus x cancels out. 3 minus 4 gives me a -1 on top. And my denominator, oh, I'm squeezing it out here, sorry. And my denominator is still going to be x plus 1. Let me see if I can write that differently. I'll write it up higher. I had -1 as my numerator, and my denominator was x plus 1. And I can't reduce anything there, even though it feels like I want to be able to reduce those ones, but I can't because x plus 1 is a unit. Okay, moving along. Can you sense my tree theme? Okay, so now, despite my theme, now I've got a little bit harder, but again, this is still going off the same principle. The denominators are the same, so x plus y is going to be my denominator. On my numerator, I'm going to have x squared minus y squared. And you might think you're done, but you need to check that numerator and say, can I do anything with it? Well, it feels like maybe I can cancel it, but guess what? I have to factor first. That is a difference of two squares. So I get x plus y times x minus y all over x plus y. So the x plus y and the x plus y will cancel because they are the same exact unit. All I have left is x minus y, and that's my final answer. Restrictions are funny with this one too. I know that basically x plus y cannot equal 0. So I could say that. That would be fine. I could also say x cannot equal negative y. I could also say that negative x cannot equal y. Any of those restrictions will work, but they all say the same thing. So if you wrote them all, you would actually be being very redundant. Okay, moving along. Now we're going to talk about when we have something that has a different denominator. So I have 1/3 minus 2/9. I can easily make 1/3 into ninths by multiplying the bottom by 3 and the top by 3. That would give me 3/9 minus 2/9, which would give me 1/9 in the end. Okay? And I can't go forward until I have a common denominator. So here I don't have a common denominator. This one has an x minus 2. This one has an x times x minus 2. So what do I need to do? I need to multiply this by x and this by x. So I get x squared over x times x minus 2 plus 6 over x times x minus 2. And then I get x squared plus 6 over x times x minus 2. And then I have to look and see, can I factor my numerator? And guess what? I can't. This is not a difference of two squares. It's not a trinomial. So it's all I can do. That's my final answer. Not a very satisfying answer, but it is the answer. My restrictions would be that x couldn't be 0 by itself. X also couldn't be 2. It's both of those. Okay, I'm moving very quickly through this. Okay, next question. I've got x minus 2 and x squared minus x minus 2. They don't look anything alike. So before I can even judge whether they're alike or not, I'm going to factor this. This one I can't do anything with, so I'm going to leave it like that. I'm going to leave 6 as is, and I'm going to factor that. And lo and behold, look what happens. I get 2 and 1, and I get negative 2 and positive 1. So I actually do have some commonality between these two fractions. This one's got x minus 2, x plus 1. This one just has x minus 2. So what if I multiplied by x plus 1 on top and on bottom? Then what would I get? Let me extend my page. I would get x times x plus 1 over x plus 1, x minus 2, minus 6 over x minus 2, x plus 1, which these actually say the same thing. They're just written in an opposite order, but because we have commutative property of multiplication, it's the same thing. So what do I get when I keep going? Because now I've got subtraction. I'm actually going to distribute this and write it as x squared plus x, and I'm going to write minus 6, and then I'm going to put it over x plus 1 times x minus 2. And guess what? I'm not done yet because I can factor the numerator. So if I factor the numerator, what do I get? X, 3, 2, minus 3 plus 2. Actually, that's not right. It's the opposite signs. It is plus 3 minus 2. I like that better because I see what's going to happen next. X plus 1, x minus 2. What can I do? I can cancel those. And my final answer is x plus 3 over x plus 1. Can't cancel the x's because these are units and they don't match. They have to stay together with their addition counterpart. So that's my final answer to that very long problem. If I were to think about restrictions, I'd go back to the beginning. Actually, I'd go back to my factored form. And I'd say, what's going to cause zeros in my denominator? X cannot equal 2. X cannot equal negative 1 because it's right here. Okay, moving along. Now I've got two denominators that don't match at all. So I have to think about what to do to make them both match. Remember this one I multiplied by 3, and this one I multiplied by 3 and 3. This one I multiplied by 2 and by 2. And I came up with 3/18 plus 4/18, and I got 7/18. Well, similarly, I can't make x turn into x plus 7 with multiplication. And I can't make x plus 7 turn into x with multiplication. So I'm going to multiply the top here by x plus 7 and the bottom by x plus 7. And I'm going to multiply the top here by x and the bottom here by x. And what do I get? I get 5 times x plus 7 over x times x plus 7 plus 2x over x times x plus 7. Now I'm going to combine my top, and I get 5x plus 35 plus 2x over x times x plus 7. I get 7x plus 35 over x times x plus 7. I can factor the top, pull out a 7, get x plus 5 over x times x plus 7, and I can't reduce anything. I thought I was going to be able to. So nothing can reduce. That's my final answer. What are my restrictions? X cannot be 0, x cannot be negative 7. Okay, next one. 3 plus x minus 1 over x. All right, first I'm going to take a different color here. I'm going to make this 3 over 1 plus x minus 1 over x. I can turn this guy into just x on the denominator by multiplying the top by x and the bottom by x. I get 3x over x plus x minus 1 over x. This one's actually a little bit easier. My denominator stays x. I get 3x plus x minus 1, which gives me 2x minus 1 over x, and nothing's going to be able to reduce. That's my final answer. My restriction would just be that x cannot equal 0 if I go back to the beginning of my problem. Okay, remember to check often when you're going through your problem sets, because it's easy to make a mistake on these kinds of problems. There's 3 more problems that I'm going to kind of whiz through. These are problems 44 through 49. They are on your test. They are on your review. They are on your final exam. So you may want to stop the video and do all the way up to 44 and then come back and watch these 3 and see if you can proceed through the final set of problems. It might make more sense than watching it now. Up to you. I'm going to write 3x plus 5, or the problem asked me to write 3x plus 5 over 3x plus 2 as the sum, addition problem, of an integer, whole number, and a fraction. So basically, my answer is going to be a whole number, that's my whole number, or positive or negative, and a fraction. Well, how does that work? Well, here's how we're going to do it. Remember, the denominator is staying the same in an addition problem. So I'm going to make an addition problem that has 3x plus 2 as its denominator. In the numerator, I'm just going to use part of it, 3x. In the other side, I'm going to use 5. Oh, I can do that, right? It's kind of like stepping backwards. But still, nothing is turning into an integer. Well, what if I actually made this 3x plus 2, and instead of 5, made this 3? If I add 3x plus 2 plus 3, I still get 3x plus 5. My denominator is still 3x plus 2, but now this whole fraction turns into 1. And now there's my integer, and there's my fraction. And that's my final answer. This one's looking for the sum of an integer and a fraction also. I want to make x plus y over x plus y. See that right there? That's going to be my integer. What's the other fraction? Remember, it has to have the same denominator, x plus y. But I didn't take care of that 9. Remember, if I went forwards on this question, I would have x plus y as my denominator, and I would have x plus y plus 9 as my numerator, just like it says there. So the final answer here is 1 plus 9 over x plus y. Okay, final question. I want to write this guy as a difference, so a subtraction problem between a fraction and an integer. So I want this side, the integer side, to say 2x plus 5 over 2x plus 5. It's going to be subtraction, so I know it's going to be negative 2x and negative 5, as it says here. So this side's really just going to say this, because I get 2x squared minus 2x minus 5 over 2x plus 5. So my final answer, because this turns into 1. And that says it in a nutshell. If you need help with these, definitely ask in class. They take a little getting used to. Best of luck with this lesson.